So today we're starting the new topic of bivariate data. So before the last major topic we did was univariate data. So what happens with bivariate data? It's when you are using you have two variables from the one source. So what that means is, say I might be collecting data, say from a group of you guys, and I might be collecting your height and your weight, and I'm seeing what happens there. Or I might look at maybe what someone earns and the car they drive. So bivariate, we're taking two pieces of information from the one source. Does that make sense like that? Yeah. So the first thing we're going to look at today is we're going to look at investigating the relationship between two numerical variables. So that before was like what I was talking about. Maybe I collect your height and your weight. That would be two numerical variables. So when we investigate two numerical variables, what we do, we end up using a scatter plot. So a scatter plot looks like this. So you might have along here, and we might have height here and weight over here. Okay, so what you're going to have is we have two variables. So and what they get called is, this one along here is often called known as the explanatory variable. In your science, and it used to be called this in maths, but they've changed it, I don't know why, but in your science and that, you'll know that as the independent variable, yeah? And then over here on the y-axis is the response variable, where you guys know that as the dependent variable, okay? But in maths, we're going to be using that one, response variable and the explanatory variable. So you need to be able to identify which one is which when you get the scenario. So say, for example, you're looking at, say, height and weight, the example I've given you. Often you can hear it if you make a statement, you can hear if it's wrong. So if you look at it, can I say my weight would depend on my height, wouldn't it? It would. If I'm taller, I would weigh more, wouldn't I? There's more weight. So my weight depends. So can you see how I said depends? Yeah. So that's the response. With the response is generally the variable that you're looking at to see what happens. Now, if you think about height, can someone's height be adjusted? It can't. It's just what it is, isn't it? It's independent. But your weight might fluctuate, mightn't it? You might be in that. But if you notice, you'll notice if you say the comment of the other one, see if I say my weight depends on my height. My height, if I say the other way, my height depends on my weight. It doesn't. Just because I get heavier doesn't mean I grow, does it? I don't go taller. No. So that way you can sometimes see that, and that's why when if you think about it in terms of your science labels, you can sometimes work it out. But it's really important because the explanatory has to go on, the explanatory has to go on the x-axis and the response has to go on the y. So if they're a little bit iffy and you don't know, they will tell you which one is. So here in our first question, I'm going to do it with you. We're going to identify the explanatory and the response. So let's have a look. We wish to investigate the relationship between age, so age is one of them, and a certain type of tree and its diameter. We want to be able to predict the diameter from the tree's age. So this is another clue of how you know between response and explanatory. The response one is what we use to predict. That's the one we're predicting, okay? So over here, if we're doing this question, A, which one's going to be our response variable? Diameter, good. And our explanatory variable is going to be age. Can you see? You can't really change your age, can you? It's independent. It's just what it is. But the diameter of the tree may change, and it depends on the age of the tree. So you can hear it sometimes in there. So let's do the next one. A study is made up of the relationship between weight loss and number of weeks a person was on the diet. So which one do you think is independent? Or which one are we looking at? What do we want to measure or predict? Weight loss, good. So that is going to be the response, and number of weeks will be on the diet will be the explanatory. All right, let's do the next one. Data is collected to investigate the relationship between age, so you can see that's a numerical, and of a second-hand textbook and its selling price. So what do you reckon we might be looking at there? Predicting? Good. We're looking at the response of the selling price and the age. I can't really change the age, can I? It is what it is. So it'll be the explanatory or the independent variable. Okay, let's go to the last one. The relationship between the number of hours of gas heating system is used and the amount of gas used. So what do you think you would be looking at, measuring or having a look? If we're looking at, we're going to probably look at the amount of gas, don't you reckon? And that one would be explanatory variable. Often time is along here, so that might help you. Maybe not always, but often that's one, so you can help you out there. And the last one, a study is made of the relationship between the number of runs a cricketer scores and the number of balls bowled to them. So what would you be looking at? What's the response? Yeah, good. So this is the response variable, and this one's the explanatory variable. Because that's independent in it. I think I'm not the best cricket expert, but you just have so many overs and balls bowled at you, yeah? Whatever. Okay, so the next part, so we're going to look at a scatter plot, which I sort of described on the other page. When we look at bivariate data, we often, when it's too numerical, we often look at a scatter plot, and we just practice working out what the explanatory variable is and the response variable. And the reason we have to do that is because when we put it into our calculator, we have to tell it which one is the X list and which one's the Y list. So we can see that's what we do. So we're going to do this one together on our calculator in a minute, but let's have a look. It's they've taken test scores from a class. So if you look at it here, you can see we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. We've got 9 students in this class. So they did test 1 and test 2. Which one do you think will depend on the other one? So which one's the response variable? What do you think that's going to be? It'll be test 2, because don't you think if you failed the first one, probably missed knowledge, but it's already happened test 1. It can't be influenced by test 2, can it? So this one we know is going to be response variable, and this one's going to be explanatory variable. So in a minute we're going to go into our calculators, and we're going to go into lists and spreadsheets. We're going to put the 2 lists in, which you can see there. And then we're going to go to, once we've got the lists in, we're going to go to a data and stat page and create the scatter plot. So I'm going to show you how to do it, but the commands are there.